Don't forget to like and subscribe or I'll come to your house and slap your bum.
So we're at a heating control job where we've got multiple controllers working the system. So this guy originally contacted us when he was doing this job, but we couldn't get here in time to get the wiring in that needed going in for the control of the system. So I gave him some advice while I was looking at it to quote it on what we would use. I'd said we'd use for your particular system, you've got a Vaillant Ecotech boiler, so we'd use Vaillant's eBus control system on this. TRVs, programmers and controllers, external weather compensation sensors, so that's all done within the Vaillant system. So at least we know we've got all the radiators covered, the hot water cylinder, the control of the boiler, and then we've also got additional zones on there. We've got an additional one zone on the VR71 then to add the Heatmiser onto the system. And he's got some electric underfloor heating in the house as well, which is controlled off like warm-up thermostats, which he just doesn't like the programming on them. He said they're rubbish to program. He said they're not consistent, so he just hasn't turned off at the minute. So I said, right, well, we could put that onto your Heatmiser system. So yeah, we've got a mix and match Heatmiser Vaillant eBus system and some underfloor heating controllers as well. So this is quite a small job. It's only a small system, but they've never used the Vaillant system before, obviously, because there's a few things that they've done which aren't right, and they've definitely not linked or used the Heatmiser system before and linked the Heatmiser system to a Vaillant either. So that's the main issue in here. So it's been working. There's been hot water on the ground floor, underfloor heating, and then also the hot water. He's had hot water in the tank, and the radiators come on when he uses his Comfort app to control the TRVs, or you manually override the TRV in the bedroom. Is that the boiler fires up when we need hot water, the boiler fires up, and then by default they're getting heat circulating around the underfloor heating when the thermostats are calling for the underfloor heating. So it's sort of working. But then he said he noticed one day that the underfloor heating thermostats were calling for heat when no hot water to the tank or to the radiators was being called for, so the boiler wasn't firing up. It was just circulating the cool water that was already existing in the system, and then obviously it was dropping in temperature gradually, so the boiler was not showing fired up. But he said, I looked on the boiler and it was showing 25 degrees, and then it was just dropping and dropping. So that's because it was circulating the already warm water in the heating system, heating loop, and then it was losing that heat through the underfloor heating, but because the boiler wasn't fired up, it was just showing a gradual drop in temperature. So you've got a circuit for the kitchen, dining area. That's one heating loop, controlled by this one thermostat here. And this is another thing as well. There's no excuse for using wireless equipment when the place has had a full refurb. So he, like I said, he did say, because we couldn't get here, that's why this stuff's been used now. There's no data cables been put in, so his Wi-Fi is not as good in the house, and he's using Wi-Fi cameras, and he's using he's using wireless thermostats and stuff like that. But the electrician that was in at the time should have said, I'll just chuck you some forecasts to the thermostat positions, or do you know what I mean? So there was a bloke in here doing the first fix, who's done a first and second fix on this, so, which is a bit disappointing really, but anyway, never mind. So these things are on batteries now and in a brand new refurb. So this one here is doing the kitchen area. Then you've got a lounge area, which is done by this one. Then you have the utility toilet, and this area controlled by this thermostat. Warm up for the underfloor heating. No TRVs on the towel rails, which I would put on personally. So there's 3 towel rails, 2 underfloor heatings on warm up, and then we've got all the radiators upstairs with the Vaillant TRVs. So we've got another warm up here for this electric underfloor heating in here. I don't actually know how they're controlled yet. I need to work that out because there's valves controlling everything else. I can't see one for tower rails. So I need to check out how they work. So this is it's a Senso Comfort controller that this has got. So it has an external, this kit comes with an external weather compensation sensor. Right, let's show you where I'm up to now. So we've got the cables, 2 3/4 going back to the plant room. We've got the thermal cut out, wired in conventionally, which we need, but we don't need the tank stat on this system because you've got the VR10 probe in there, which is controlling switching the boiler on and off basically when it knows that the stat has got to temperature. I've not even managed to confirm these loops yet because we haven't actually had any hot water flowing from the boiler because the boiler's not been firing up. Where I'm up to. So this is the drawing that the guy was working off, which is wrong. So he's got their S8 to underfloor heating demand, whereas actually it needs to be in the S7. So that's incorrect. And then also the zone valve for the underfloor heating should be in to, there you see it's crossed it out, it's scribbled it out. So he's done them, like a conventional style joint. So what we need to do is probe flow. So there's a probe missing as well, S3. So again, this is the drawing he's been working off, which isn't right. So this is, I've had this emailed to me now via Vaillant. So this is the correct drawing. Yeah, so we've got underfloor heating, zone valve goes into the R2 connection, which it doesn't currently. And then also we have S6 is linked out. S7 is our normally open underfloor heating demand. And then also S3 is the underfloor heating output, temperature probe, which we don't have. So we're missing the, there we go, we're missing the, so we have no underfloor heating temperature probe, which is a VR10. So we've got a spare one here. So we need to put, which has not been put in the first place, a VR10 on the flow pipe of the underfloor heating. We need to put a link in 6. We need to put our contactor connections in S7. And once they're all satisfied, we need to make sure the programming is correct in here, which is on this bit here. So there's certain settings that we need to put into the programming to make sure that this operates as an underfloor heating system. So these are all the things that haven't been done. And then also the wiring hasn't been done correctly as well. So yeah, you've got a cable coming in here which is bringing in switch lives and stuff for the hot water, which is fine. Basically this zone valve for there, it should be in the connection in here where there's nothing in any of the other connections apart from hot water and radiators. So we're missing the power being picked up out of here, and then also the signal, and then we're also missing a pipe sensor on here, which is obviously telling you can see on the system, on the Senso Comfort, it will say that the pipe work is this temperature. So the system needs to know what temperature the pipe works at, the water's flowing, it's heating up, it's cooling, so it can work efficiently. Another reason why you need this underfloor heating manifold motorized valve connected directly into the VR71 is because when the boiler is trying to heat the water cylinder, it will close all the heating valves and direct all its attention to heat the water cylinder. So like I say, this is the brains of everything, so you need to have the relevant connections in here. Make sure they're all bang on, because the way this was wired before was that it was just jointed out and activated manually by the pump live in here, which was also activating this relay. So that relay, all the connections are just stuffed together and away you go. So the boiler then can't isolate this because it's got a permanent supply coming from this, allowing water to flow through, which the pump is also on, which is dragging the heat into it. So if this is trying to redirect all its energy down the domestic hot water loop, it can't, because the underfloor heating is dragging the heat away from it to heat this, and all this stuff is open and functioning because it's on a different system, it's on a Heatmiser system. So then the water cylinder isn't going to heat up as quickly or as efficiently. So yesterday I managed to get the underfloor heating running independently from the radiators and the hot water, because that was the only way it was working before, if the radiators and the hot water were on. So we managed to get that working by boiler firing, and then left it running overnight. Left the temperature at 25 on all the thermostats just to see if it had the ability to climb up to that temperature. It's warm down here, and I've checked the floor already, so all the loops are heated. So what I'm going to do today is, well, first thing this morning is I'm going to prove all the loops go to the correct areas and make sure the right thermostat's controlling that area. Because the system wasn't running properly, it's not been tested properly when it was laid. They just kind of did the installation, set up as much stuff on the Vaillant controls as possible, set as much Heatmiser up as possible, but it wasn't running properly. The programming wasn't done correctly on the Sensor Comfort. There was cables, there was wiring that was missing or incorrect in the VR71, and then once that's all set up correctly and then all the wiring's done, then we need to run the underfloor heating system and just prove that that's functioning efficiently and, you know, and everything's connected correctly. So these checks weren't done when it was first installed, and just because they were getting some hot water, we're getting some heat to the radiators and a bit of residual heat around the underfloor heating, they just made it, you know, the assumptions that the system was working. So I set all the stats to 22. Let's turn them up a bit so we can see how hot we can get them. I did set these at 25 last night. Okay, so this room's at 21, this room's at 19.8, this room's at 21.6. So you've got, you can see the floors okay here. Toilet. So that's supposedly controlled by this one, but this is what we're going to prove now. But this is just showing that we have got the heat functioning in here. Yeah, so that's good. So we've got the heating functioning independently. So actually now I'm going to isolate 2 of the circuits and just make sure that that the correct thermostat is doing the correct job. So I'll turn these 2 off. Okay, so 2 of the zones have just gone off on there now. We've just got zone 1 on, which is here, this one. So we'll just leave that now. And then I'll go through with you what I had to do here to get this functioning. Right, so this is what I was working off yesterday, and this is, you know, the ideal type of information that we need to try and get to the bottom of things. The more information you can provide, the quicker it makes the process of trying to find the issues rather than just going in completely blind. So we've got manuals for all the equipment, yeah, which is handy because we need all that information to set up programming for the relevant system that's been used. Sensor comfort schematics. We've got a layout of the pipe work, which is all good, so we can see where everything goes. But again, I always prove it regardless, and I do prove just to make sure that we see where the pipe work goes and we can see how many loops are in there. But once it gets back to the manifold, this is where the issues normally happen. Is if this hasn't been labelled up correctly, then there could be an issue with controlling the wrong circuit, or if all these are labelled up correctly, which most of the time they are, and then all the actuators have been put on incorrectly in the wrong order, connected to the wrong thermostat, so then that's another point of where we have a crossover. So we've got pipes labelled up incorrectly or incorrect connections onto the correctly labelled pipes. So this is helpful as well, so we can see the layout of everything. So basically it's this that he's printed off. So he's had that book I just showed you at the minute, and so they'll say, right, we've got this type of system, we've got this type of control. There's the wiring diagram for it, for the connections in the VR71, and then there is the setup for it. For the sensor comfort, the OT switch off threshold is for the external weather compensation sensor. So if the temperature gets to 30 or above, it will switch the heating system off because it's not required because it's too hot outside. Yeah, so that's what that's for. So these need to be set correctly. The max flow temperature is, the pipe sensors are all on the pipe work and they detect in the temperature of the water flowing around the pipes. So when it gets to 70, it knocks the boiler off, and then it drops, then fires back up at the minimum threshold, the minimum temperature that you've got. So on here, there's no actual required minimum target flow temp. So on this unit, I had a look at the target flow temps, the minimum target flow temps, and they were set at like 30 I think, 35. So that the radiators and the underfloor heating, whenever the boiler was heating, it'd heat to like 35 degrees and then cut off and then drop all the way back down to 30 or less and then heat back up. So the water in the pipe work flowing to the radiators and the underfloor heating was no more than 35 degrees. So, and they were saying that the house was feeling cold, and like, no wonder. So that's why it's important to get the settings done correctly on this and according to your personal circumstances as well. So these program settings need to go into this specifically for the type of system that we're installing. Yeah, then you can personalize the max flow temperature. So the underfloor heating, for example, it's got a maximum of 45 allowed to flow through it because of the temperature restriction, you know, the valve on the actual underfloor heating. So that's set at 45, so it's never going to be more than 45 flowing through the underfloor heating. So I've got that system set at just at 50 now, yeah, and then it loses a few degrees from the boiler to the underfloor heating manifold anyway. Whereas the upstairs radiators, that can be set a lot higher, so the water flowing to them is a lot hotter. So that's something that you need to put in here as well, because his heating system was running cold anyway. So that was a few issues with this. None of the programming was right in this. And this is the diagram that he was using. So on here, on this diagram, so he's printed this off out of this book probably, or from a PDF as well. He could have just printed it off of a PDF that they sent, because apparently there was a lot of back and forth with Vaillant technical support, Heatmiser, and also the plumber and the customer were all, you know, between them all trying to work out how to do this. So here you can see that he's got the connections there in S8 for the underfloor heating there. So that S8 was the incorrect connection. So that's why one of the reasons why this wasn't coming on. So this was the first indicator. This data here is the first indicator of like issues. And then also just a quick visual inspection, and then when you start getting into it, then you find a few more as well. So this was the wrong type of, the connections were incorrect on here anyway. And then also you can see there it says underfloor heating. That's where the actual motorized valve for the underfloor heating plugs in to R3. Now he had the underfloor heating just in a joint box. The underfloor heating motorized valve just done conventionally in a joint box, picking up a supply from a relay and activating it with an external pump. So the way he'd done it was, like I say, a traditional way, using the greys and the orange switch pair in the motorized valve. Actually, that's not the way to do it on here, because on this Senso Comfort, it'll tell you that the valve position is open. So if you don't use the connection here, this unit is sending a signal to this, sending voltage to this 230 volts to open the valve. So this unit controls the opening and closing of the valve, and then it's actually got indicators on here to say, you know, that the heating is on, the valve is open, and water is flowing at this temperature. So if he's got it connected a different way, this is actually, it's not reading correctly, because it doesn't know whether the valve's open and closed, because it's not using the voltage on the unit on the VR71. So have a look. Install level. Right, so this is what you would do. You go into the installation configuration to edit all this information here. This is where you would go, and it will say there installation. So installation, and then that's got this settings within installation there that you need to edit. So you see there, adaptive heat curve activated, adaptive heat curve. We need to make sure that that's activated. Yeah. External inputs open, deactivated. External inputs open, deactivated. If these aren't in the correct positions, the system isn't going to function properly. So that's just showing you there now while we're here. Anyway, so that's the menu that you're going to go into to edit all these settings. So we were working on circuit 2, which is underfloor heating labeled there below. So circuit type heating, status heating. So it knows now that the boiler's calling and we're heating the underfloor heating, or that heating circuit, whatever it might be connected to it. Target flow temperature, actual flow temperature, right? So that's what I altered yesterday. So his radiators and underfloor heating was set at 30. So I've done the minimum flow temperature for the underfloor heating specifically at 45, because no more than 45 degrees can flow through that pipe work. So I'm going to crank that up to 50 actually, because the rooms could probably be a bit warmer. So maybe there's a bit of loss between the boiler and underfloor heating and it's not full 45 getting through. So I'll crank that up to 50 anyway now, and that's changed that setting, yeah. So the minimum flow temperature I am asking for is 50, and then once it reaches 70, if it reaches 70, it will just cut off and cool back down. It's on the menu here that something is active, the valve is open, the pump is on, so use the facility of the connections that are in the unit rather than trying to manually do it. Vaillant's advice was to remove that underfloor, to remove that motorized valve and put it into the correct connection. So rather than picking up on the relay again, which I'll show you how it was done in a minute, use the correct connections. So if there's connections in here for, you've got your sensor connections and you've got your output connections to motorized valves, pumps, etc. Use them connections. Don't try and manually do it yourself, because this unit is measuring, it's constantly measuring data from the external temperature sensor, from the pipe sensors that it's getting information back, from this control unit here, and then all that data it's getting, it's switching relays on and off to do the job efficiently. So you might make the system run inefficiently. We had to take all these out of the Wago connections so I could get into the back, because it's hard to see where all these cables, because there's cables on top of cables there. So there's flexes going up, down to the fabric, to the pumps, to joint boxes, to actuators, up to this unit here, up to that unit there. So it's very confusing when you look at it to try and like get your head around it first. So you have to start taking things to pieces to see where everything goes. So basically, the upstairs radiators and the hot water were functioning, but not functioning efficiently because of the programming of the Senso Comfort, which I've gone through already. The wiring issues. So you require a relay, an open and closed, a normally open, normally closed relay to activate these volt-free contacts on this unit. Yeah, so they're getting, these contacts here are getting signals from temperature sensors, and they're getting switch signals. So the S7 connection there activates the R2 connection. So when this gets, in this case, a normally closed, I thought it was a normally open signal, but actually on this, when it's receiving a normally closed signal is what's activating it. So this was, so it was wired into the S8 connection, which was the wrong connection anyway. So for what he needed to do was, there was a pipe sense, so just for the underfloor heating to function with the VR71, forget any of the Heatmiser controls, just so this works with this, he needed to add a pipe sensor. So there was no pipe sensor on the underfloor heating, so it's not getting a signal back to the unit to tell the boiler to fire up because it's at 40 and it needs to get back up to 50, or for the boiler to cut out because it knows that it's reached 50 and now it's hot enough. So without the pipe sensors it doesn't work. Yeah, it's not getting the signals it needs, and it's not going to switch these relays properly if it's not getting the signals it needs. So we'll put a pipe sensor on there on the flow next to the manifold. So that's what's giving us, reading our temperature, and that's how we're able to, as I showed you before, set the max flow temperature and the minimum flow temperature, because this knows what that is. Without that it doesn't read anything. So that needs to go in the S3 connection, your underfloor heating temperature probe, yeah, which is a VR10 you need. It has to be the correct temperature probe as well. Then in S6 you need a link, so link out S6, and then your connections from your relay board go in S7, and then once all that's satisfied, it will activate this R2 connection, which you put your zone valve in for the underfloor heating. He had this connected into this board here with all this gear here, and then what happened, then basically this pump connection here, once the thermostats were calling, this gives voltage to the pump connection, which was activating this relay, which was then also jointed in the back of here onto a load of other stuff like external pumps, zone valve, etc. So it was bypassed that, and it was powering this zone valve and activating this external pump also, as well as that pump, using connections in here, using this pump connection here. So I've took that back out of there now and put it straight into here, into the R2 connections. So this is what juices this now, and then this does the work for all this then. So that's how you get these two things working together. This bit has to be satisfied, then this bit has to be satisfied. When I got this bit, I didn't touch that, and I didn't touch this at first. So I did all the stuff that I just mentioned then, yeah, and then I activated the underfloor heating, which powered this, which fired the relay, but then nothing happened. When I turned the thermostats off, it then put this into the normally closed position, because it was connected into the normally open position. When I turned the thermostats off, the relay went off, it closed that, and then it fired up this R2 connection. So it's sort of, after I did the wiring, it was like sort of, it was functioning then, and it was functioning backwards, and that's because the relay connections were done the wrong way around in here. So I changed the relay connections to the normally open position, and then once the relay's activated, it's normally closed, and then it closed that connection, which then opens this, fires the boiler up, etc. Yeah, so there was wiring issues in here, then there was wiring missing in here. So that's how we sorted that problem out, getting the boiler firing off the VR71 via the Heatmiser. So today now I'm going to make sure that now we've got the Vaillant controls working, now we need to focus on this side of the control and make sure that it's switching the correct zones, make sure the thermostats are switching the correct zones, making sure the rooms are getting to temperature before I leave. So I'm just measuring the temperature in the room with my test instrument, which gets calibrated. So this is very accurate. Yeah, it gets calibrated every year. I'm using an app, so this is an app based unit. This is reading 20.4 and this is reading a room temperature of 22.4. So this is 2 degrees out. So if they have got this set at 20 and they think 20 degrees is more than hot enough for me personally, because that's the temperature they normally like the house at, they've actually got the corridor set at 18 degrees. So when I come in here, it does feel like considerably cooler than like 22 degrees. It doesn't feel like 22 degrees now. I could tell that that wasn't the temperature. But yeah, so that's why we need to recalibrate all these to the same temperature as one calibrated temperature sensor. So we just do this as standard anyway. If it's 2 degrees out and you've got all your thermostats around the house set at your desired 20 degrees, actually you set it at 18. That's why a lot of people will crank these up and they're reading 25, 26 degrees and they think that's ridiculously hot, but it's actually not 26 degrees in the room. It's just you have to crank this up to that to get it to the ambient temperature that you want. And that one is reading on mine 20.3. So look at this one. I mean, this isn't in a good position anyway because it's behind the fridge. So a fridge is giving out heat usually at the back. So you want to put the thermostat somewhere where you're not covering them up with anything, especially not a heat source, because if this is producing heat, that's going to read that temperature and then not allow the heater to come on in this room. So that one is reading 20.4. And then the probe is reading 20.4. So that one is actually accurate. So this one's accurate. That one's 2 degrees out. That one's like 1 degree out or something. So we're going to recalibrate them all to this meter. And then we've isolated the zone now, which is labelled toilet, utility and hall. So this stat being here, you know, they probably don't shut that door, so that's an okay position to have it. It's doing the hall, it's doing the utility, and the bathroom might get a bit hot, you know, because it's only a small room, so it might be quite a bit warmer in there than what it would be in the hallway and in the utility. But if the pipework is split up into separate areas, like separate toilet and separate utility, then we can't split it into any more thermostats because it's just one pipe zone. So in here, after I turned, as you saw before, all the floor was glowing, but that's when I had every thermostat open. So now I've just got it on. This one is open, which is utility, kitchen, which is utility, hall and WC, it says on there. So we've got that thermostat calling. Yeah, we've got the right valve. The valve is open, yes, for that particular zone. What it says on the pipe work, yes. So then we'll have a look that what that pipe says is correct. And what you can see is it's kind of like at the edge of just coming out of the toilet wall. So yeah, the way the pipe work's been laid, it's not actually in the hallway floor, it's half coming into the hallway, not even half, it's a quarter into the hallway. And then the utility is just that bit on the left hand side, so basically it's underneath the washing machine, so it's half of the utility. So this circuit serves half of the utility, a quarter of the hallway, and all of the toilet. So it would probably be more accurate to put that thermostat in the toilet, really, because that's the room that's going to get the hottest, because it's got the most pipe working, the most relevant pipe working. So the only issue is in here is if we have this on, if you say you don't want the utility on, if this is off and you don't want this utility getting warm, you have no choice but for it to get warm due to the route of the pipes coming for the kitchen loop and for the lounge loop. So if the kitchen and lounge are calling and the utility isn't, this room is still going to be very hot because all the pipes run through with no insulation on them to prevent them heating this room up. Yeah, so that room's always going to get hot whichever zone's on. So that's kind of not very relevant for that and not very useful for the utility. And then also the bulk of the hallway was lit up when the kitchen and the lounge was calling, and again that's just the route that the pipes have taken through here to get to where they've got to go. So that again is not, that thermostat there is not very accurate, because at the minute this isn't going to warm the hallway up very well, but when all the units are calling in there, this hallway is going to be very hot. It might turn that off and then it will turn that little quarter off there, but it's still going to be a very hot hallway. Now that's just how just the way that the pipes have been run, is going to affect how we can control it and separate the control for each individual area. So yeah, that's a bit of a problem really, but nothing we can do about it now. That's how the pipes are laid. Oh, there you go, you can see the you see it does there actually. So it does that strip too, sorry. So it does that bit underneath the washing machines, then it does the front door, and then it goes through to the toilet there where it's brightest. But then you turn around and this bit of hallway here is not. So yeah, well, we're going to get some heat obviously from that area there with the door, the front door, which I suppose is the most important area because that's your drafty spot. But yeah, that could go in the toilet or it could go in here, but it's going to give false readings for, if it's out here the toilet's going to be very warm, and if it's in there it'll get to temperature very quickly and probably never bring this loop on because the toilet will be a lot warmer a lot quicker. So it's difficult to split that. So I'm going to just do the other ones now and see how they're working. Right, so we've had this stat running for a little bit now in the lounge. So we can see that check that the loop's heating the correct zone and that it's heating the floor efficiently. So yeah, this looks nice in here, looks like a nice even spread of heat. So this room will probably perform quite well because there's not much glass in here and stuff as well, so this should keep quite warm in here. And then you can see this is the path through the kitchen, past the door there for the cylinder, and then this is what's going to potentially give some false readings in the, and then also the kitchen, which will be next to it when I do that one. So you got a string running right through here, which is the lounge. So if this door is shut, for example, this room's going to accumulate some heat dependent on how long, I can feel it under my feet here, dependent on how long the lounge is being on. So that would potentially give this a false reading and turn the heating loop off in here, which would then turn the heating loop off in the toilet and it would be cooler in there. So maybe that could give you some issues with that. And then also similarly, there's a strip right through the middle of the floor in here, which is going to also be giving you residual heat in the utility room. So this room might be, well, this room will be extremely warm if the utility, kitchen and lounge are all calling for heat on a cold day. The utility room is going to be very hot and there'll be no control over that. Right, so we're just checking the kitchen loop now. So that's set, I think I'll set that at 25, so that's been on for maybe 40 minutes now. We've got zone 3 on the UH8. We've got kitchen zones open on the actuators. And then again, here's the kind of, like I said before, like the conflicting heat sources. So we've got further right now, there's another two pipes there going out, or 4 pipes, whatever. And then in the middle, more so in the middle of the room now, you've got the heat in here. Seems to do that little bit of stairs as well. So again, that there will be giving this an incorrect temperature reading in the room. So that circuit now that's hot and that does that little bit of staircase is the kitchen. It's heating part of the utility floor, part of the hallway floor, and then it's doing the kitchen. So yeah, this particular little area here is difficult to control accurately. So then there's the kitchen heat. Yeah, so that is good. Yeah, so we know that that zone now is definitely controlling that. So that is we can isolate that now. So as you can see on this unit, this is a Neo V3, I think it's a V3, V2 or V3. I'm assuming it's a V3 because they're new. It's got an option of having a floor probe or air probe if you wanted, whichever type of temperature sensor you like. So in this case here, he's got floor probes going to all the areas from the thermostats as well. So as the reason why you would use them is if you want to protect the flooring, to make sure that the flooring never goes beyond a certain temperature, then the thermostat will shut the valve off when it's getting to that temperature. So you've got two ways of protecting the flooring. So an example of flooring that you'd want to protect is this stuff, which is engineered, I'm assuming it's oak. So it's like a plywood, softwood base, and then it has a veneer of about 6 mil of oak on top. Yeah, so you need to buy flooring that is suitable for underfloor heating, which a lot of times people don't, because it'll void your warranty if you fit flooring down over heating pipes and then it all warps and cracks and twists and brings the glue away from the joints, or splits all the oak on the top. The company, you'll try to take it back and the company will say you've had this fit on the floor heating, your warranty is void. They can also say the same thing if it has had too high a temperature running through it. So that is what the temperature regulations for as well. So we've got temperature regulator on the underfloor heating manifold, and we can set that to max 45, 40. So as you can see now, the boiler is at 64, but the maximum temperature going to go through this is 45. I've got it set at 45. So no more than 45 degrees is going to run through these underfloor pipes anyway, due to that. So that's protecting the temperature of the pipe. That is regulating the temperature of the pipes, which then protects the floor from damage. But then you've also got this other option of one, if it's a huge room and you want to add an air temperature probe down the other end and you don't want to have two thermostats, you can put either wireless probes, or in this case you could use a wired air probe and put it into your Neo Air and it will read multiple points of the temperature of the room, or as is used here as a floor probe. So again, this is reading the floor temperature as well, but you need to put that in the programming and tell it this is the temperature that I want it to turn off. Otherwise it won't, it'll just be sat there not doing anything. So he's got his kind of secondary backup probes as well to protect the flooring. The system is now functioning how it needs to be functioning, but there is still some alterations that's going to need to be made, and this, like currently, this needs to be sat in the right place, or when there's some updates made with TRVs, which I'll just explain, the settings need changing on this. So the upstairs, which I've shown you before, has got TRVs on. So this is where this is still doing a job as a thermostat, but it needs to be in the right room. So that was just kind of out here. So all these rooms upstairs, there's a radiator over here that's got a TRV valve on it there. So, and then the rest of the rooms as well. And then there's bathrooms that's got a normal manual thermostatic valve on, but the other two bathrooms don't. So all the rooms that are covered with the radiators with the TRV valves, TRV there, and then in this bedroom as well there, and then in this bedroom too. So all the radiators up here except 3 of the towel rails are covered with the Ambisense TRV valves. So they work on the app So on the controller, we've got circuit 1, which is radiators upstairs. That's on its own individual circuit controlled by a motorized valve. So we're controlling circuit 1 currently with this controller. But if you were to put this, for example, so this is set for desired temperature 18 degrees, and we put it in here, current room temperature, so it'll be, let's see what it's at. So current room temperature is 21, desired is 20. Yeah, so if this room, for example, never has that TRV on and it is freezing cold in here, that's going to be calling for heat even though the TRV is switched off on the app. So you've got these conflicting thermostats here then, so that is doing the control and making sure that this room stays cold because that's how they want it, but this is reading the temperature and trying to fire the boiler up because it is seeing it's below the desired temperature. So we still have them 3 towel rails that aren't controlled by anything, so this needs to stay in one of these rooms with this, because this is measuring, this is firing the boiler up and controlling the towel rails only, because the TRVs are controlled for every bedroom via an app, so they already have their control. So this needs to stay in the bathroom with one of the towel rails. That is then reading the temperature in here. It'll drop below 20 degrees and then it will bring the towel rail on, and once it reads the temperature in this room is 21 degrees, it will turn that off. So that is still doing a job of controlling this towel rail and the other 2. When he gets the TRVs on this, on all 3 radiators, towel rails, because that's what he's going to do, the temperature sensor on this is then obsolete because everything has its own control. The Heatmiser has their own thermostats and programming. The TRVs have their own thermostats and programming. And there's no temperature to sense and to control. So you need to go into the settings of this once everything is covered with TRVs and you have no radiators just on no thermostatic control or whatever. So it's like I say, that criteria has to be met, and then this is what you need to do to isolate. You need to basically inactivate this. Yeah, so once them final TRVs are on upstairs and he has full control over every room of the house, we don't want this reading the temperature and switching the boiler on and off because we already have that control. So what you'll need to do is you go into settings, install a level, installation configuration, and the circuit we're controlling is circuit 1, which is the radiators. So you go into circuit 1 and then you have room temp mod expanded, so you will want to change that to inactive, and then that will then isolate the temperature sensing mode on this unit, and then you'll be using the control that you've got from all the TRVs, from all the Ambisense TRVs, and then from all the Heatmiser controls. So at the minute that's staying in expanded because we are still controlling the towel rails with this. But like I said before, once they've got TRVs on, there's no need to have this in temperature sensing programmable mode. We only then use this as a programmer for the boiler and all the settings on the boiler, and it can just go in a cupboard somewhere out the way because it doesn't need to be in an area where it's sensing the temperature.